This is the 6.4 section of proving triangles similar using the shortcuts of side, 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 and side, angle, side. So let's take a look at the first shortcut, which is side, side, side. So if corresponding sides of two triangles are proportional, now that's a key word there, proportional, not congruent, then the two triangles are going to be similar. So in this case, I don't even have to check the angles, but I am going to have to check all of the sides to make sure all the sides are proportional. So when I do that, what I do is I take a look first at the smallest side on the triangle on the left, which is 12. And I'm going to compare that with the smallest side on the triangle on the right, which is 4. And that reduces to 3 over 1, or 3. I'm then going to take the medium side on the triangle on the left, which is 15. And I'm going to compare that to medium side on the triangle on the right, which is 5. And that's going to reduce also to 3. And then I'm going to take a look at the longest side on the triangle on the left, which is triangle JKL, and that's 18. And I'm going to compare that to the longest side on the triangle on the right of triangle XYZ, which is 6. And that reduces then to 3 as well. So in this case, the two triangles are going to be similar to each other because the sides are proportional. They're not congruent, but the sides are in proportion with each other, reducing to a scale factor of 3. Now, one of the things I want you to look at is the similarity statement itself. Now, in this case, my similarity statement is triangle KLJ similar to triangle YZX. So I started here and I did K and then L and then J, and that's similar to triangle YZX. Now with this statement, I can use a different statement if I want, because I have power over how I list the angles of the triangle. I could do a different order if I wish, as long as I keep the angles in corresponding position. So K's got to go with Y, L's got to go with Z, and J's got to go with X. I can write a different similarity statement. And I did that here below. I did triangle JKL is similar to triangle XYZ. So again, I kept J, all right, in corresponding with X, and I kept K in corresponding order with Y, and I kept L in corresponding order with Z. So you do have a little bit of flexibility when you write your similarity statements, but the angles have to correspond with each other exactly. Otherwise, you will not have similar triangles. All right, so now here is the side angle side shortcut. So in this case, if I have two sides that are proportional with each other and an angle included between the proportional sides, then I'm going to have similar triangles. So in this case, I've marked angles L and angle Z congruent to each other, and then I need to check the sides around that to see if they're proportional. So I'll take the smallest side on the triangle on the left, which has got 15, and compare it with the smallest side on the triangle on the right, which is 5. That reduces to 3. Then I'm going to take a look at the bigger one, which is 30, and compare that with the bigger one on the triangle on the right, which is 10. And those both reduce to the same exact number of 3. So because I have two congruent angles and two sets of proportional sides, then I have similar triangles. So triangle JKL is similar to triangle XYZ. At that scale factor, whatever those numbers reduce to when I'm checking the proportionality, that's going to be what my scale factor is. So let's take a look at some problems. So I want to check to see which of these three triangles are similar. Maybe they're all similar, maybe none of them are similar. And then if I figure out the similarity, I want to know the scale factor. So I'm going to check the first and the second triangle. So I'm going to check triangle ABC and triangle DEF first. So I'll take the smallest side of triangle ABC, which is 16. That'll correspond with 12. And then I'm going to take a look at the medium one, which is 20, and the medium one here, which is 16. If those numbers reduce to the same scale factor, I keep going. If they don't, I stop. So in this case, when I take 16 over 12, I can factor a 4 out of both of these. This becomes 4 over 3. And then 20 over 16, I can factor a 4 out of both of these, but this becomes 5 over 4. They're not the same. And since they're not the same, I can stop. I already know the first and the second triangles are no good. So now I'm going to take a look at the second and the third triangle. So maybe these two triangles are similar. So again, I'm going to take the smaller numbers. So the smallest side length here is 12. The smallest side one here is 20. And then the medium one is going to be 16. And the medium one here is going to be 25, and I'm going to check those. So I'm going to check those, and we'll start first with the 12, and the 12 over 20 goes to 6 to 10. This reduces to 3 over 5. And then I'm going to check 16 and 25. I can't reduce this fraction anymore. 16 and 25 is like as far down as I can go. So I know the second and the third one is no good. So now that leaves me to check the first and the third one. So I'm going to check this one, ABC, and triangle GHJ, and see if they have proportionality. So again, what I'm going to do is I'm just going to take my smallest number. So my smallest number here is 16. The smallest one here is 20. And then I'm going to check my medium one, which is 20 and 25, and see if I've got proportionality here. So when I reduce those numbers, okay, I can factor out a 4 out of 16 and 20. So this becomes 4 over 5 because 16 is 4 times 4, 20 is 5 times 4. I can factor out a 5 out of 20 and 25. This is 4 times 5, and 25 is 5 times 5. So they match. So I keep going. I check and see whether or not I've got more going on here. So I have to check the third side length. So the third side length is, longest one is 24 and 30. And here I can factor out a 6. 24 is 4 times 6, and 30 is 5 times 6. So I factor a 6 out of both of those, and I now have a matching set of ratios. So I have proportionality here. So the triangles are similar. So triangle ABC is similar to triangle GHJ. So I do that in the correct order, and the scale factor then is 4 to 5. So let's take a look at these two triangles. Are these triangles similar? Okay, triangle ABC and triangle DFE. So in this case, I'm going to use angle. I have an angle here congruent to another angle here, so I just have to check two sides because I have an angle that's included between them. So the smallest one for triangle ABC is 20. The smallest one is triangle DFE is 4. That reduces to 5. And then the larger side is 25 for ABC, and the larger one for DFE is 5. And those also reduce to 5. So I do have similar triangles here. The triangles are similar because of side angle side at a scale factor of 5. So when I write the scale factor, I go triangle ABC is similar to triangle DFE. Right, similar type of problem here. What do? I could use side because I have all three side lengths, but I think it's easier to go side angle side because then I have to do less writing. So I'm going to go side angle side on this particular set of triangles, and I'm going to check the smallest side, which is 6, with the smallest side, which is 3, and that reduces to 2. And then I'm going to try the medium side here at 8, and the medium side here at 4, and that reduces to 2. So the two triangles are similar to each other. Now the question is, how do I write this statement? Because the triangle over here is flipped. So when I'm going triangle ABC, I'm starting with the smallest one and I'm going to the medium side. So if I say triangle ABC, then I've got to do the same thing here, go with the smallest to the medium side. So this is going to be triangle FED. So this would not be triangle DEF. This would be triangle FED. And then the scale factor is 2 to 1. All right. So similar type of problem here. Which of these triangles are similar? I can't use angle. So I only have one angle here. I have one angle here. I don't have any angles here. So I'm going to have to use side. So we'll try the first and second triangles. I'm going to go 5 and 4, and I'm going to go 7 and 6. And neither one of these can reduce. Another thing you could check always is cross multiply and see if your cross multiplying works and equals each other. 5 times 6 is 30. 4 times 7 is 28. 30 and 28 don't match. So we know the first and the second one are no good. So we'll check this one, the first and the third one. All right. Smallest side is 5, so 5 is going to correspond with 2. Medium is 7, and that's going to correspond with 3. And we could check the cross products here. I get 15 and 14. They're super close, but they're not the same. So that one's no good. That leaves me with the second and the third one. So I'm going to go, smallest one here is 4. The next one is 2. And I've got 6 and 3. And 4 over 2 reduces to 2. 6 over 3 reduces to 2. And then I'm going to have to check 7 over 3.5. And 7 over 3.5 also reduces to 2. So these all work. So if I did cross products here, like that's 12 and that's 12, this is 21, and if you punch in 6 times 3.5 in your calculator, you're going to get 21. So they are. Triangle ABC and triangle GHJ are similar to each other at a scale factor of 2 to 1. All right, next type of problem. Show the triangles are similar and write a similarity statement to explain your reasoning. So I don't have a third side here, so I can't use side, side, side. I don't have two angles, so I can't use angle, angle. Question is, can I use something like side, angle, side? And I can. I have vertical angles here. Hopefully you remember that. I have vertical angles, so I could do side, angle, side. When I set up, like how am I going to set up whether these are proportional? Sometimes students will go like 14 to 18 and 27 to 21, and that's not going to work here, okay? You've got to do like side lengths in like their ascending or descending order. So 14 is not going to correspond with 27. 14 is going to correspond with 21 because this is the smaller of the two numbers on this triangle. Triangle ABC, this is the smallest number. On triangle RSC, the smallest one is 21. So I'm going to go 14 over 21 and then 18 over 27. So when I check these, this reduces to 2 over 3, and this reduces to 2 over 3. So the triangles are going to be similar to each other. So the similarity of the triangles, I'm going to go triangle A, B, C, okay? But these triangles are swapped. So this is going to be triangle SRC, not triangle CSR or something like that. So the corresponding parts are triangles ABC and SRC. All right, here's another one. Again, I want to check to see if the triangles are similar. I don't have a third side here, so I'm going to compare this little triangle here with the big triangle here. It's on the outside. So I have to use corresponding side lengths on triangles, and that's a really big deal. So I'm comparing the small triangle to the big one. My side lengths are not going to be 3 to 1 because 1 is not the side length of a triangle, and neither is 2. But 3 and 1 put together is, and 6 and 2 is. And then I have a reflexive angle A. So I can do side, angle, side. But when I do the side lengths, I have to compare them at 3 to 4 and 6 to 8. And when I compare 3 to 4 and 6 to 8, I do have proportionality. And if I check the cross products, 3 times 8 is 24, and 4 times 6 is also 24. So these triangles are in fact similar. All right, last problem. This one's super tricky. Are the triangles similar, or which ones are similar? Well, you probably are going to notice right off the bat, because I know you're pretty astute, that triangles B and C have 3 sets of congruent side lengths. So this side is congruent to this one is congruent to that one, and this one is congruent to that one. So those triangles are going to be similar. Now the question is angle A in this deal at all? And I do have an angle measure at 32 degrees, and over here I have an angle at 58 degrees. So if I can figure out the measures of one of these angles and see if we have a match, we'll have similar triangles. So if I take 180 degrees and I subtract my 90-degree right angle, that leaves me with 90 degrees. And then if I subtract my 32-degree angle, that's going to leave me with 58 degrees. So the truth of the matter is, because triangle A is going to be congruent to triangle C, and triangle C is already congruent to triangle B, actually all 3 of these triangles are going to be similar to each other. So it's kind of a involved, tricky problem, but they're all similar to each other. All right, that brings us to our assignment. So for Monday, I want you to go to page 385 and do questions 1 through 3. Don't send them to me, just hold on to them. Tuesday, do page 385 again at questions 4 through 6. Hold on to that assignment as well, so keep those both together. Then on Wednesday, I want you to do questions 7 through 8 and 10 and send all 3 of those together in an email. So that's all going to come together, so 1 to 8 and then 10 in an assignment. And then the Thursday assignment, I want you to do questions 11 and 12. Friday, do 13, 14, and 25, and then send Thursday and Friday's assignments together in one assignment. And I do want to warn you, for number 10, 11, and 12, you need to justify your work. If you just put yes, I'm not going to give you credit. Hopefully you found this presentation helpful. Thanks for watching.